Hi everyone, I'm Nurul, and today I'll briefly take you through my dissertation titled Planned Obsolescence of Data Architecture, a Retroactive Manifesto. So this is the cloud where the internet lives, basically. Despite the ethereal guise it assumes, data actually takes the form of a sophisticated physical network. And these are the type of spaces that weaves infrastructures called data centers into existence. So demand for data centers are steadily growing despite energy concerns, and we can anticipate the growth of the data economy to be fueled by the remaining corners of the world yet to be connected to the internet. So this is exemplified by this diagram by architects. Despite these demands and energy concerns, some data centers have a good relationship with their cities. They make up for their huge energy appetite by channeling their residual heat to neighboring buildings. So this is exemplified by this diagram by Norwegian architect Snohetta for one of their data center projects. So Amsterdam also has a symbiotic relationship with their data centers. However, heat demand from the city cannot always be met by the low supply of residual heat from data centers in winter. So we go into my research agenda. So the entire research is centered around this data center, the Equinix AM4. I'll be calling it AM4 from now on, by Bentham Crowell Architects. It is one of the most celebrated data centers in the world, despite adopting the shape of the prevailing box typology. It also challenges the idea of data centers being invisible, as infrastructures tend to be. This windowless behemoth has succeeded in gaining acceptance in its city. However, like other buildings, it is subject to obsolescence. So enter the quantum computer. Based on numerous articles, once fully developed and ready for the market, current data centers will not be able to cater to the needs of the quantum computer, which runs at a temperature of absolute zero, which is minus 200 degrees Celsius. So this advancement will render AM4 and other data centers alike obsolete in about 30 years' time. So this is the future scenario that I've adopted for this dissertation. So this obsolescence timeline, I call it, aids in shaping my research objectives, particularly concerning the proposition of alternative uses for the data center as it becomes obsolete. This dissertation aims to propose a second life for the sophisticated 21st century data center, aligning with the 2050 European timeline for climate goals and social and economic targets. So leveraging the abundant materials found in data centers, this study navigates the tenets of circular economy to plan the repurposing of the modern ruins as the era of quantum computers begins. This study assumes a scenario by 2040 where half of the building becomes vacant due to functional obsolescence. Now, Amsterdam's housing crisis necessitates the swift utilization of available space, with data centers emerging as potential solutions for new homes. So AM4 is regarded here in the study as a material bank, housing reusable materials set for disassembly and reassembly elsewhere. In preparation for phase 2, remaining spaces are repurposed into material storage rooms or even a small-scale production yard. No materials leave the site, aligning with the intention to fully utilize AM4's many building elements. Due to its depth, which is about 30 meters, it is not practical for the housing program to take over the entire depth of AM4. However, the residual space holds potential for indoor urban farming and research lab, which don't require daylight like its previous server occupants. Incorporating the data farm program not only ensures AM4's continuity as data center, effectively delaying its obsolescence, but also acts as a contemplative reflection on its historical significance. So just quickly, AM4 is located in University of Amsterdam Science Park campus, which is at the fringe of the city. So the staff and the students of the university are the ones who are expected to support the future functions of this retrofit. So this is just a view of the building in its context. It is the tallest building around, so it's not being overshadowed by anything. And much like most data centers, the floor-to-floor height is quite generous. Each floor is 6 meters high and currently houses data servers. And this is just a typical view of really any data center around the world. So the purpose for the study is important that we establish similar architectural characteristics of data centers worldwide, including materials. The materials chosen to be studied are generally used in data centers and have a lifespan longer than the building's use. So in theory, if the data center in Amsterdam can be fully refurbished into housing using its own skin and bones, other similar data centers can do the same. So the other aspect to take into account is each component's ability to be disassembled easily and reassembled elsewhere. This is just one of the few more detailed studies about each material that I've done. So this is an example of the facade panels, which later utilized as wind barriers and also some sort of shading device for summer. So environmental context. So Amsterdam's climate is pretty similar to the UK, with much cooler winters. So the southerly facade of AM4 gets more sun, while the northeastern facade and northwestern core receives very little sun in winter. All facades are well exposed to the sun in summer months. So layout configuration. So the first design task for me was to conceive a layout that works within the structural confines of AM4, and the base case design scheme was, in my opinion, the most obvious route to take. Housing units would line the perimeter of the building with generous windows and depths not exceeding 8 meters. So this is essentially apartments with single aspect units. So the central space would still house AM4's data while it goes through decommissioning and acts as a material storage or assembly warehouse before the final phase. Then the design took a turn where it investigated the possibilities of maybe not being a compact and enclosed building, but instead an open building, allowing more light into the center for the first time in the building's life. This decision would, of course, have obvious impacts on the thermal performance. Compact and closed buildings are always better for heating dominant climates, but I wanted to investigate what would happen if, I would propose much better open spaces for the users. So prior to the plans, the design was tested for its solar exposure, and some amount of volume is taken out on the southern side. This development of design also allows for double aspect units and would potentially help the units on the northern side to get more solar exposure. Just a quick study on housing. So this is a few diagrams called housing biographies that traces a person's personal space throughout their lifetime. So to summarize, the older a person gets, the more personal space they have. And with scarcity of space in Amsterdam with the housing crisis, it's something that we should consider. Also, the Dutch government intends to rehouse the elderly into smaller spaces to make room for growing families. So keeping this issue in mind, I've proposed a generational unit to keep future families together and provide the Dutch with bigger future-proof spaces. For the residential units, there is a mix of single-aspect duplex and single-volume units. Later in the simulations, 2 spaces are tested for environmental performance: the single-volume bedroom, which is only 3 meters high, and the generous 6-meter-high living kitchen. It is essentially a test to compare volume spaces rather than individual units, as we're dealing with the standardized floor-to-floor height used in most data centers. The lighting and wind. So just quickly, as expected, a double aspect layout would allow more daylight to enter its units, but winter overcast skies generally keep indoor illuminance levels at a minimum. And a quick study prior to this showed that units with a generous window-to-wall ratio, about 40%, performs better in winter, and that is the ratio that is being used for this study. Just a quick section showing the spatial arrangement of the atrium, open-air atrium and units, as earlier shown. Summer months may provide a bit too much daylight than required, although through conversations with locals, it is always welcomed in Amsterdam. This is where the facade panels come in handy as operable shading devices for the southern units and potentially for northern units as well. Next, we address one of 3 garden terraces proposed in the design. Now, because Netherlands is a windy country, opening up the building may increase discomfort levels. So, using the facade panels as not facade panels. Putting up a wind barrier at the garden terrace would help create a more comfortable, comfortable conditions in the terraces. So it's reducing the 7.7 meters per second wind to a pleasant 3.5. So this is where we are at now, essentially what it looks like from the south. These are the southern balconies with the reused facade panels. Some views in the atrium. And these are views looking into the atrium. These are showing the units which are a bit more shaded. And all these renders are actually during winter mornings. So thermal studies. So we start thermals with base case with double glazed windows and existing sandwich panels. So these are the existing units that I am reusing without any additional materials to the existing fabric. A set point of 20 degrees is used since studies have shown that this is the most comfortable for the elderly, since we are proposing generational units. In free running mode, it performs below the comfort band, but with a heating set point of 28 climbs into the comfort band. The bedroom appears to be doing well without heating, attributed to its smaller volume. Then we go to the test case, where the building is more open, but with improved glazing and added insulation. And because we are opening up the building to provide better daylight and public spaces, additional materials are added so that it could at least match the performance of the base case. So here we can see the living room is still in free running mode, still below the comfort band. So the northern units, I think, self-explanatory. Because it's in the north, it has less solar exposure, so it's not performing as well as the south. This is the same for the living room in the north units. And then when we go to summer, there are periods of overheating in the living room. So these are tested in the southern units. But with the application of external shading, it performs close to a scenario where internal blinds are used. So with these strategies, temperatures in the summer can be kept within the comfort band. So as a summary to my thermal study, at best, the large volume space performs best as a single aspect unit, but with certain strategies, a double aspect unit in a more open building can perform just as well. So all strategies are within the Dutch heating and cooling load requirements, which are a maximum of 25 kilowatt per hours. So these two cases are more of options. It's not saying if the enclosed one is better or the opened one is better, but it's really just investigating what kind of layouts AM4 can cater in the future. Carbon studies. So after being more informed of the suitable materials through simulations, we go back to evaluating the selected components. So from the data center, certain materials have been chosen and to be reused during retrofit. All the components are fully utilized somehow or other in the retrofit, but there is 30% excess of facade panels and hollow core slabs that are unused. The excess and additional materials are quantified for the following carbon studies. So using the FCBS carbon tool, we are able to see how the new materials attribute to embodied carbon of the retrofit. If using the RIBA 2030 challenge, there's room to improve the embodied carbon. So I went back to fully utilizing the concrete slabs as floors instead of a timber floor system, just to see how it affects the embodied carbon distribution. And it has improved enough to get it within the 2030 range. So it's clear how we choose to use our materials affect carbon calculations. And with the same design scheme, the FCBS tool tells us that we have to plant an equivalent of 90 football pitches worth of trees just to offset the whole life carbon values. And I leave you with a thought about how we can go shopping for construction materials in existing ones. In existing buildings, sorry. Thank you.
Right, good evening, everyone. My name is Abhilash Menon. The title of my thesis is Factory Reset, Adaptive Reuse of Textile Mills in Mumbai into Affordable Housing. A quick introduction. Under the British rule, 600 acres of now defunct land in Bombay was allotted for the development of the textile industry in India. This historic map shows the number of textile mills just in this particular region of what was then known as North Bombay, but is today Central Bombay, wherein my site is located. A quick timeline of the history of events. 1854 is when the first textile mill was opened. By 1932, two-thirds of the city was employed in the sector. Things went south in 1982 when the workers went on strike demanding higher wages, and in the early 90s, the government changed the land regulations and rules, which ultimately led to the mill owners cutting their losses and selling their land to developers, who inevitably would demolish and build high-rise residential and commercial buildings, which leads to the narrative of the city's lost heritage as shown in popular tabloids in India. Here we see another historic map showing the area which had most of these mills. This is the area which is now gentrified, leading to the displacement of middle-income and low-income groups to the peripheral suburbs of North Mumbai. These images by photographer Johnny Miller highlight the disparity of the housing situation in Mumbai today. A staggering 40% live in slums, and it is estimated that the deficit of dwelling units is 2.7 million by 2036. The illustration by Dirk Simmons shows how Mumbai compares to global cities in terms of density. All the circles have 1 million homes in them. The skyline of Mumbai today, with multiple high-rises, and in the bottom left corner, one of the few remaining abandoned textile mills. So moving on to the climate analysis, Mumbai experiences tropical monsoon climate as per the Köppen-Geiger classification of climate. The annual temperature graph can be divided into three distinct categories: two very hot periods before and after the monsoon period, followed by a moderately warm period. On average, daily solar radiation is between 4.5 to 5 kilowatt hours per meter square. For the maximum daylight test, one would check for glare within the space, and the minimum daylight test would ensure one would test a minimum to ensure 150 lux for a residence. So again, the climate band. For the purpose of my research, I will be using the IMAC comfort band, which was developed in CEPT Ahmedabad. They found that Fanger overpredicted the sensation of heat at temperatures found in warm climates in his PMV method, which is the basis for all comfort bands across the world. And the occupants in India were more adaptive at high temperatures, especially naturally ventilated buildings. My three test periods within that. And the IMAC tool also allows for calculation of comfort bands for future scenarios based on minimum, maximum, and mean temperatures. So that's how the temperatures would overlay between 2020 and 2100. The graph shows that the upper limit will not change beyond 32 degrees, but it's just as a prolonged period of 32 degrees as the upper limit in the comfort band. Moving on to the site study. This is the area in which, as I've said before, it's in central Bombay. And a land use map shows the surrounding context consists mainly of private housing to the west and east, along with some government housing. To the north and south, there are other abandoned textile mills as well. To the far west, railway land. An image from Google Earth shows the thick growth of vegetation that has taken place over the 40 years. The site has sat abandoned, which provides for better microclimate opportunities. Natural ventilation helps reduce soil air temperatures on the ground facades, whilst also cooling surrounding areas due to evapotranspiration. Moving on to my particular site called India Mills United No. 5. These are just general images of what the structures are like in Mumbai today. So I made a block model consisting of the three main blocks along with the ancillary blocks. So this is how my site looks. And upon cutting a section, we can see the different roof profiles and heights of the main blocks. Moving on to project feasibility, various studies were done ranging from analysis on income groups across the city and housing data inventory to prove affordable housing is optimal for this particular site, but I'm not going to dive deeply into it at the moment. The graph shows the average size of the family in the state of Maharashtra, which has now reached a steady number of around 3. Based on that, I formulated the distribution of my 1, 2, and 3 bedroom flats. If we then multiply the total area under the 3 main blocks by the floor space index, or floor area coefficient as it's known in the UK, we get the total buildable area permissible of 27,800 square meters. We then put that distribution back into what we saw earlier, and we arrive at the number of 1, 2, and 3 bedroom units. However, after designing, the total built-up area obtained was 22,750 square meters, which equates to an FSI 1.6. This then equates to a density of 300 units per hectare, or 900 people per hectare, which when compared to a typical high-rise of FSI 3 or 4 is far superior, as you can see. Moving on to the climate analysis, the predominant wind directions are west, southwest, and northwest, with the average speed in summer of 3.1 meters per second used as the input for CFD simulations. Just cutting a base case, doing an analysis of the base case shows that the north block has way too many patches where the air is stagnant, and opening it up 50% in the roof profile, as shown in this section, shows a definite improvement. So moving on to placing the blocks within them, the street to width ratio of the blocks was based on an observation from a case study in Porto. This is that said model wherein the street to width ratio was 1:2. And the CFD results from that case study, as shown here, show that a minimum of 1 meter per second moving through the blocks, which is the minimum requirement for physiological cooling. I then tested that and 6 other blocks, which I'm not going to dive into, but the crux of it is that the north block was the one that was not getting the required levels of ventilation. And until finally I reached the final form, which basically has chamfered edges and a lot of gaps between the blocks to allow for free flowing of air through it. Lastly, the windows on the ground floor were brought to the sill level for better movement within the blocks. And these are the final results, both on a cutting plane of 1 meter at ground level, as well as 9 meter for the highest stories. It must be noted that there was a 50% increase from 1 to 1.5 meters in doing so. Coming on to solar radiation studies, the base case is definitely going to be inadequate. Opening up the roof, as we saw earlier with CFD 50/50, proved to be too much, wherein it was almost 2/3 what the solar radiation would be outside, which is far too high when compared with the case studies. What I was aiming for was around 25%. Sorry, what I was aiming for was around 40% as per the findings from my case studies, which was finally this much, 25% of the outdoor solar radiation, which is the right amount for the required amount of light, as well as preventing overheating. Annual UDI levels, usable daylight index, as well as daylight factor between 2 and 30%. So my test day was 6th of July, which was a monsoon day, and the 2 test times were 8 a.m. and 5 p.m., where the solar radiation is 3.16, which is very low, as mentioned earlier. And these were the lux levels within it. So basically, to summarize, midday on the worst, most cloudiest day, if there's 18,900 lux outside, inside the existing structures, that would be around 2,276, whereas the daylight factor, the units need to be designed with a daylight factor of 1.5 to 2%, thereby allowing the required amount of lux hours for residents inside. Before moving further with the design, I'd like to highlight a research experiment I conducted during the summer break in Bangalore in India to study the effects of indoor comfort due to ceiling fans. A temperature measuring instrument was used to record the outdoor temperature and then the indoor temperature. And to summarize, with the fans on, the spaces have temperatures similar to that of outdoor conditions, showing a delta of 2 degrees Celsius compared to when the fan is off, and that will be factored into the final thermal simulation results. Form development of the blocks. So the type A blocks are 3 stories high, and in the north and western block, following the principle of form follows ventilation, the units were designed to have double height space on the side, on one side to assist with buoyancy and wind-driven ventilation through a stack effect. The inlets would be in the living spaces, and the hot air exits out through an opening in the top of the double height space through a smaller opening. Of course, there'd be an insect mesh as well, and this would also be a transition space for the bedrooms above. So the basic size of the block would be 9.5 by 6.5 based on the areas for the units required. An additional unit attached in reverse with a shared wall. Chamfering the edge as per the form developed in CFD earlier, leading on to the final form with the 1-bedroom unit on top. This is what these units look like. The floor plan basically shows, so they are also 1.5 meters sunken into the ground from site level. And so the living, dining room, and kitchen are open plan with the powder room downstairs, and the 2 bedrooms on top share a bathroom. Sorry. The walls which have the adjacent, have the window adjacent to them, have a brick cavity. Sorry, there's a brick cavity wall in which the windows slide 100% in to allow for maximum ventilation. The change in U value was factored in as well. Similar 1-bedroom mirrored, but with the chamfered edge, and the 1-bedroom unit on top. The input parameters for daylights, and I'm going to only show the results for the monsoon days. This was the type B block, which again is just a variation, and the 3-bedroom unit, which is longer than, very similar to the 2-bedroom, but with a bedroom in the ground floor. And that leads on to the final form, which sort of looks like this. To then an isometric view of the site, and if we cut a section through the site, it would look like this. And the last block that I just showed you would look like this. So the bottommost has the 3-bedroom, above that the 2-bedroom, and the 1-bedroom units on top. And doing a CFD simulation justified the, The CFD results of the units was overlaid with the sectional drawing. This was based on the form alone and wind-driven ventilation. To test buoyancy-driven ventilation, I will have to simulate internal gains due to equipment, lighting, and occupants. Lastly, thermal comfort. Outdoor thermal comfort studies were done, and the temperatures were all within the comfort band of the IMAC comfort band. These are the input parameters for my indoor study. Grasshopper script was used to convert the infiltration rate from meters cube per second per meter square of the facade to air changes per hour. I'd like to, so one simple way to visualize thermal comfort results is by just calculating discomfort hours, the number of hours for which the temperature is above 30 degrees in the year, which is the upper limit of my comfort band. The 3-bedroom performed the best, as seen here, due to it being on the semi-sunken ground level with the typical week temperature graphs. This is the worst performing unit. It had exposure to the west, southwest, and northwest, and it had an average of 2% discomfort hours. I'm just going to quickly move on to the visualization. Thank you very much.
Well, thank you very much, both of you, for very well researched and very well presented projects. Ingrid, would you like to say something?
There's 2 really impressive projects, and I think it's this course is a very challenging course because you are within an environment of a level of a kind of explorative architecture that's going on in every corner of the school. And yet you're engaged with a degree of scientific rigor that is often absent. I mean, sometimes you get a fantastic technical study in 5th year, but it's hard to apply this much data and still end up with an architecture. And I think for both of you in particular, this has been really successful. I think with your project, there's something really beautiful that sun and wind have almost eroded this crazy building that looks literally like a hard drive that sits under your desk, but at the scale of a building. And then similarly, I think that there's a sense of place that you have in your project here, which allows a kind of domestic vernacular to take form in this really unusual circumstance. And yet I'm completely overwhelmed by the data that you've produced. I suppose there's a question of the architectures that emerge if you had another year. To what extent, there are aspects of coming off the orthogonal, because obviously it's so hard to measure, and I have a very, very minimal understanding of the way in which you model these things. I know from working with Kuhn for many years that the frustration of being able to model particular thermal performance as you design is tremendously problematic. It's not like measuring light, which means that complex forms presumably become very difficult to work with as you, again, have to assimilate all of this data that you're collecting. I don't know if there's possibilities, there's ambitions to create more complex three-dimensional form. Not that I think that that's the answer, but it's interesting that you end up with things that are relatively orthogonal, relatively coherent within their architectures, and whether that's a constraint of working with the data or if that's an architectural ambition. I'm kind of curious.
You can go first. You can go first.
Sure, respond.
For me, if I understood the question properly, I think for me, very stubbornly, I might add that I really didn't want the simulations to shape my building because I just didn't want it to. So, but it is an SED program, and I've learned so much, and it's just trying to find a balance between the two, trying to meet in the middle, and then it's not necessarily the best form that I'd like to come up with, but I'm just fortunate because the data center is just a box, so it's a lot easier for me to design within, and it did make it a lot easier for me to simulate my units because everything's just boxes and rectangles. I think it was just a coincidence that I was working with the simplest forms to model. Yes. We had to sort of modify certain grasshopper models, some U values that we need to sort of calculate ourselves because it wasn't available in the library. But I don't think it was that too hard, for me at least, to get the numbers. I don't know, Abhilash.
Yeah, well, on the contrary, mine was completely shaped by CFD simulations, as you could see. And well, I think in the internal blocks, there is a bit of, because of the arch shapes that's created by the stack effect, I think that does lead to an interesting form, but yes, there is scope for more exploration.
I suppose the question is, do you want it? Does the software hold you back? Or
Well, I think personally, I think the targets of the what is comfortable, that would be holding us back mainly, rather than the software.
It's a pity you missed the first two presentations which were very remarkable because of the way in which they put the analysis to the service of form and form was produced, and it was interesting because it was not just form, it was an idea. From the numbers, something completely non-linear and fully grown.
So the others can hear you.
Oh, sorry. Well, but that just failed. I mean, maybe we should bring them back for you to...
It's okay. At some point I have to go. But maybe also, this isn't the only day we can see the work. I'm here every day.
Good.
But it's really impressive.
Open
It's really
invitation.
impressive.
Thank you.
And a real pleasure to see. It's a lot of information to assimilate into
Yeah, it is.
and to still end up a project that has architectural integrity. Congratulations.
Thank you.
Thank you.
Yeah, well, I think it was a
very interesting comparative, and I think fortunate that you show two kind of retrofitting interventions on two building types that are quite paradigmatic. One of from the past almost, or from the present, the manufacturing place, and the other is the data center, as considering the obsolescence of a building type that is still emerging in a way. And I think it's interesting that both of you took, although the buildings, the initial buildings were completely different, took a similar angle, and in the sense that both of you decided to retain partly, not entirely, the existing scheme, the envelope, and to build the second one, so that the original envelope of the building is a second scheme for your project. And I think that potentially could also lead you to well, if you have this another year, but to further explore the potential role and the opportunities that this space between the old and the new scheme could provide in the sense of adaptability of the building. I think it's a little more clear in the case of Amsterdam, where the climate is cold in winter, warmer in summer, and then you may want a more compact building in winter and more exposed and open as it finally is in summer. Whereas in Mumbai, perhaps, is, well, the challenges are more homogeneous all the year round. Well, it gets hotter at some part of the year, but I think in both cases, because in Mumbai, you have this brick wall, so provides additional thermal capacity that could be also used to have these transitional spaces that perhaps part of the year could become the most comfortable spaces in the whole complex. So I think that's interesting that both of you, different climates, different building types, in this, I think, commendable objective of minimizing demolition, minimizing the use of materials, keep partially the existing structure, that eventually you both follow not so different approaches.
Thank you, Jorge. I really liked your presentations. I like how systematic you were with your studies, with your analytic studies, to come at the end with a design proposal. I agree with Jorge. Your two buildings are very strong, elements or products. And although you approach differently, Nurul, you were more worried about the carbon footprint, and you, Abhilash, you were more worried about the thermal comfort. However, what I think was nice to see in the way you approached your challenges is that, Nurul, you although it is in stages, you kept mainly the inside, although for temporary, and you were trying to design something meaningful on the surrounding. And you, Abhilash, the opposite. You retained very strongly the structure outside, and you tried to develop something inside. And I think that these two different approaches were nice to see how you developed your projects. Thank you so very much.
Thank you.
Hi guys, I'm going to be brief too. Nurul, just a quick question. You mentioned at some point that you have a farm inside in the future, third phase.
Initially, it was something like an urban farm, but now it's become, in my thesis, you'll read about it, it's become a data research center where people plant plants and store data in them. So it is an urban farming thing, but...
It is still, yeah. Because I think something we saw throughout the day and was very interesting for me is to see how, by working with existing structures, we start seeing you looking at the object first. Of course, you have an idea of a program, but there is an element in which the building forms the brief rather than the brief defines the building form. And in almost every single case, we saw that And I think it's brilliant because it's a piece of creativity, but it's also a pragmatic approach, understanding the reality and contributing to better environments. And the moment we do that, we also saw a combination of programs. So not just urban blocks, but buildings, even not so big buildings, becoming multifunctional. And then what does it mean for environmental design and for architecture? What synergies can we extract from that? So I was thinking in your case, this internal planting, does it create a climate there that is milder than the outside, although it's still enclosed? Then I was wondering how enclosed it really is, it needs to be. We don't need to have all this discussion now, it was just questions that were coming. Because it can definitely define opportunities for design and new environments through these synergies. Maybe that's something we should be studying more. And then, on the other hand, you do something I think is very brave and courageous, and I also admire a lot, which is, you mentioned, going against the status quo, the business as usual, minimal exposure for this climate when it comes to residential units, and opening two sides. I mean, Ingrid mentioned several layers. So it's really doing the opposite of what the energy, environmentally correct standard building is in this kind of places. Challenging that, creating more exposure, but with that bringing more quality, diversity. And I really like to see this kind of work that just offers an alternative to the boring box with the right orientation and the good window. Now, when it goes to Abhilash, what I see, lots of numbers, great, some are resulting in design, but I would have loved to see you starting by saying how good it is to be under this umbrella that you found, which is your warehouses. It's building under this roof that allows the building to be more open, and you did all of that. I just think you are too, how can I say, maybe dry to the quality that is there. You know, the moment you go under that, the streets are cooler, the windows can be bigger, people can see each other more, you communicate more, you can open more the buildings. And that's your entry point, I really think. You already have a level of protection there that allows a different architecture, maybe more like the bungalow that we were looking as a reference from some time ago, nearby areas where you could open more the buildings. Anyway, just this quality and this alternative that you both are putting to even the environmentally correct buildings in this climate, I think is very encouraging. It's great to see. But you must bring that single and very good quality right at the beginning. That's my advice to you. But I've enjoyed very much your project. Thank you for great presentations. Yeah.
Thank you.
Thank you. I don't know if all presenters are still here, but we have a few, so I would like to invite the audience to ask any question or a comment, provide a comment, please, for those who are here, if you want to join here. Don't be shy.
Right, so to Devi, who is also designed in the same city as I have, I found that the complexity of his existing fabric was far more difficult to deal with, and I think I really commend the whole design process he chose to have for his thesis.
Maybe just to move to another kind of question about the process of producing a dissertation project. Its joys and, well, non-joys, and the problems of submission, and the reason for example, that not everybody's here, because you feel that there is a clash, there isn't enough time. I mean, how was that process? What would you like to say that will help our new students and will help us to help students with the process and completion of the dissertation?
Okay, I'd like to go first because it's something that I realized immediately when I started writing my thesis. I know this is hard to do, but I realized if we just started writing during term, every time you present during mid-review or final review, you're able to present your ideas clearly. There's more supporting data. Now, when I look back to my midterm review, I was like, what was I presenting? It was just like, was it grounded in facts? No, but I think that was something that I wish I had done earlier, writing at the same, while designing at the same time, not a full thesis, but at least, just a draft maybe, I think, yeah.
Great advice for everyone. I think also time flies by very fast. You don't realize how fast the thesis goes.
Yeah.
Like at the start, it feels like it's like 8 months to go, but at the end, it's like so fast and so many things to do that somehow you're all over the place doing things. So I think planning a bit would also help, which is like an individual thing, but like planning the entire process of, or having like an overview of like what kind of research can be taken upon and how much should be taken upon according to the course, I think would also help in some sense.
I have another question of that kind, and it is that the movement from group, from team to individual, which is, in our case, in the case of our program, it's quite dramatic, isn't it? Because for 2 terms, it's group. And you become very well acquainted with each other, and you seem to be able to distribute the work. And then you are single, and all of a sudden there's 10 different procedures, software, etc., some of which your colleague knew and you didn't. And what happens there? I mean, because, well, we know that several times there's a discontinuity that forms, which is quite dramatic for some people. So, I mean, it would be nice again to hear from you and how to improve upon that.
In my case, I got the help every time I start doing a simulation, for example, because simulations were new to me, but some of our teammates have more experience. So whenever I was stuck, I was still trying to get information from them. So for me, we weren't separated at all. And then like I kind of feel more secure in simulations, for example, and then try to figure it out some other things, for example, in Grasshopper by myself. So I didn't let them go immediately when I start my individual projects.
I would like to raise a question. You don't need all to... Hello? It's okay. You don't need all to respond, but I would like to hear at least from some of you is we asked you from the beginning to engage with architectural ideas. We do have a strong analytical base, but it was very clear that we wanted this to come hand in hand with architectural ideas. So we are not just calculating and then have an idea and design with it. Mm-hmm. How much can you interlock both or work with both? Each of you had a design process. We don't have a recipe for an architectural design process. Even analytically, we don't have a recipe, which I think is great about this course. We have the tools, we have the principles, and then each project will be a project. You would also design your methodology, and you did. But what would be interesting to know is at what point in this process you felt you had a clear, not project, but process. Okay, this is my design process. This is how the analytical and the architectural concept, they create something. Did it take too long for you to get to that point? Do you get the question? Is it? What do you think?
For my case, I started right away with designing, and then start testing them. Started testing my design with the tools. But personally, what I like to see more is that starting with the simulations and then starting the design. But this can change in every project, I think. But I felt more confident when I start a design and then start improving it. That was more maybe my style of architecture.
And improvement, you mean analytical?
Analytical. With analytical tests, I try to improve that design. So maybe like from the beginning, I wanted to do adaptive reuse, but in the end, I completely designed a new building. Maybe because I was stuck in that, I tried to make an existing building better. Was my first intent of coming to this program. Maybe because of that, I started like that. That was my personal experience during the design.
In my opinion, I have a different opinion to what Berg said. I think the analytical and the design go very hand in hand. It's not about like analytical at the start or design at the start. They always go hand in hand. It's just to find the right balance between the two, I think. Like sometimes analytical show you things which are not like possible practically in design, but sometimes design required to do things where analytically they don't work. So I think the right balance that you find between the two is something that I think, like, that's how I gradually go step by step by doing things, I think.
Let's see now. Yeah, you wanted to ask.
Yeah, it was kind of like already been answered, but first of all, I wanted to thank you all for your presentation. It's like very encouraging to see where the tools we're learning can lead us. So thank you. And I was wondering, because we're being exposed to new ways of thinking and learning new tools and new data that can be overwhelming at some point. So, but I find that it's extremely important to go back to architecture. So if you have any advice of how not to get lost in data and bring back the architecture, or the balance that, okay, Divi was already saying, but do you have any advice or something you would have done differently in the process?
I think usually what happens is that the start of the course, you start to learn a lot of tools, which is why you dwell into a lot of like data analysis side, but people don't understand that the tools are like mere things to understand building physics. So if you understand design and understand building physics, then you know what to test on it. I think people just go forward into like exploration mode, saying like there are 100 things taught, I will do 100 things. But it's about narrowing down those 10 things that are required in your design and only test those things out. I think that's the best approach.
I'm going to sneak away, but I wanted to first say thank you, but I think this is a really important point. I've now sat through a bit of housing and urbanism, a little of landscape urbanism, and now you. And being clear about what you're not doing is super important. I think the presentations I saw this afternoon were very good on this. You're very specific about what you're using in terms of data, the kinds of objectives you set yourself. It's incredibly important because otherwise you do everything. Having said that, I had a really good advice, like starting a PhD a long time ago, someone said, you're going to get lost. If you don't get lost, it'll be banal. So I think a little bit of getting lost and then a really clear, within the context of the thesis in particular, clarity about the objectives of your work, I think, and that's been very exemplary today, actually. So, really well done. Thank you.
Maybe a loose note.
We can close? We can. Okay. celebrate.
We should celebrate.
Yes, definitely. But
Thank you so much.
and we have a lecture at 6:30, okay? With the
Jorge Rodriguez, speaker. Yeah. Thank you.
Thank you.